Hello guys and welcome back. So let's keep on building our logic here. Now there are some design flaws of our setup. One thing is that, well, we're getting a random primitive, but what if that random primitive doesn't have any neighbor, right? That could be like a problem. And also we're artificially say 1,000 times iteration. But what if it's already done with 200 iteration? Then there's no need to do the rest of the iteration, right? So it's not ideal, right? It's not performant and it's having some problematic setup. Okay. All right. So one thing you can take a look at is that here we're assuming that we got something, right? So we're getting a number that is from the number from 0 to 3, so we're assuming there are 4, right? That could be problematic. We need to know how many are we getting. So that's one thing we need to do. Let me Alt E to open this to make it bigger. Okay, so of course it's not going to be always 3. It's 3 in the first settings, but there could be situations that there is like only 1 neighbor or 2 neighbor in this case, so this has to be varied. Right, so instead of like say 3, it's going to be a neighbor count. So we're gonna go for neighbors. That's the variable we're having here, right? It's gonna be this guy's length here. Okay. And then because it's kind of like off by 1, so we need to minus 1 there. That's gonna give us a more accurate result. Okay, that's one thing. Okay. And also, well, there could be situations that we don't really have anything, then there's no need to do all these things, right? Because then we're gonna, it's basically when this is empty, then we're getting arrows, right? So I'm gonna say, okay, well, if the length of this neighbors is not equals to 0, so we actually do have some neighbor found. And that's when we want to do all these things underneath, right? So we're gonna copy all these things over to here. Okay, else we basically don't do anything, all right? So if we do that, then here the chosen one, not chosen, will be just empty if there's nothing in the chosen, right? So it's gonna delete everything. So you know, it's making something empty and merge with the original ones. So in theory, it should be just fine. Right, so apply and accept that. Okay, this should be a little bit more sophisticated, right? It's like something we handled here. This is not part of the logic, the actual calculation logic, but this is like something needed for handling errors or situations, right? So we kind of wanted to have those code to deal with problematic things like that. Okay. All right, so yeah, that's one thing. And then we were doing all these things together, right? And we repeat more and more, like this is like 1,000 times, right? Well, there must be one, oh, you know, at some point there must be like nothing to merge anymore, right? It could be 200, it could be 300, who knows? But it's gonna be, you know, a position that, you know, an iteration that just went over everything and it's already all merged. There's no neighbor for any primitive anymore, and we don't want it to keep on going, right? We don't want it to keep on doing that. So I'm gonna go create a attribute Rango here and just to test that. Okay, so in the Rango node, I'm gonna go for a details. We're gonna loop through all the primitives available for now. Okay, so I'm gonna say int prim count will be equals to number of primitives of our first input. Okay, and then I'm gonna go for a for loop. Okay, for int p equals to 0, and then p is smaller than prim count minus 1, because you know the count is bigger than the available index, and then we increment p. Okay. All right. So this syntax is more seen with p++. I'm doing ++ p. In theory, based on the implementation, it could be the same, but in lower level language like C++, ++ p is a little bit more performant than p++, so that's why I'm doing that, but shouldn't be that much of a difference anyways. Alright, so I'm gonna go have a little space in there just to make it easier to see. Alright, so we have this, and we just need to go ahead and try to check every primitive and say, okay, do you have any neighbor, right? Neighbors will be equals to poly neighbors. Okay, we're asking for every primitive, do you have a neighbor, right? So we're going to say if neighbors, well, it's length, of course. How many neighbors do we find? If this length is like equals to 0, then we want to say, okay, well, there's nothing. Oh, actually not equals to 0, because well, we want to check if there's any, right? So we're going to check if there is any in this case. And if there is, then we're going to say I at stop equals to 0. So we're not stopping yet if there's some. And then because we found one already, there's no need to find another one because it is already saying that we need to go for another loop. So I'm going to say break. That way we don't need to go through all the primitives all the time. As long as we find something, then we just keep on going with the loop. And to start with, we can assume that I at stop will be equals to 1 first, right? So we assume that there's nothing more, but we check. If we find even just one of them, we just say, okay, we find something, we need to keep on going with the loop. So keep on going, right? And then we can also say, in the very end, just to verify that what is going to be the count, right? I'm going to say, okay, if at stop equals to 1 after all the checking, we don't find anything, then it's going to be equals to 1. I want to say, okay, I need to know the current iteration just to verify like how many times do we want it to go through this. So I'm going to connect that over to the second input so we can reference to its detail attribute. Int current iter will be equals to detail of our second input iteration, and then 0. I want to say I at final iter will be equals to this current iter. Okay, all right, let's take a look. Cool. So final iter is 0. I guess we haven't reached to the very end yet, so it's keep on going. But if we keep cranking this number to like 1,000, okay, you can see, well, final iter is actually 999 and stop is 1 there afterwards. So we know that it's actually 999. If we keep cranking that up to 10,000, you can, let's wait for this to calculate. Well, the final iter is that much, which is actually wrong because we kind of want it to be, stop is already 1. Oh yeah, it is 1, but it's incrementing because even when the stop is 1, we keep on going, right? That's not that. So we need to know, okay, if there is a stop, we want it to stop, right? And luckily there is a stop condition here. We can check. Okay, if we change that to 1 in the very beginning, it's not gonna do anything, right? So stop condition will be the one we need to kind of like use. Okay, and by the way, I don't want it to go for 10,000 times. This is too slow. Let's just go for like 1,000 for now. Could be already too much. Yeah, the stop is already 1 when we were like 1,000. So let's create a null node. Probably don't need a null node, but yeah, result, right? I'm gonna check if the result is having a value of 1 for the stop, right? Let's ask for detail, and then result. Okay, is your stop attribute 1? So we just ask for the stop attribute. Okay, you can see it's 1 here, right? So if we go check, yeah, it's already 1. Not sure why the stop is 0 now, but let's create another null node to take a look at the final result. It's changing it to 0 for some reason, but this one is 1 and the final is actually 281. So even it says that we're going to try to do 1,000 times, even you give it one more 0, it's going to stop at iteration 289, because that's when it doesn't really need a more iteration anymore, right? Which is good. All right, so that way we're limiting it to as much as it needs instead of trying to go through a whole lot of times. Okay, pretty cool. So now we have all the things laid out, and there's nothing to merge anymore. And also here, if you do recall, we have a seed. So if we tweak the seed, it's going to be like different every time, right? So we get like very different result in this manner, which is also pretty cool. Okay, so so we have our internals, we have the outside. Let me create another null here just to be able to put them together really easily. And this is going to be the edge, and this is going to be the, you know, the internal. Let's do a merge here just to take a look at what does it looks like now. Okay, cool. All right, so we have the edge as a bunch of grid, right? And for the internally, it's going to be a bunch of big and smaller panels. Now for the panels, we want to process them to get some more detail, of course, right? So let's go through that. Maybe, yeah, its time is gonna be a little bit long now, so we're gonna go ahead and move on to the next video, and we just process those things piece by piece to add some details. Okay, see you next time.